Hello everyone, in this video we are going to be looking at balancing redox reaction in acidic and basic conditions. So before you continue looking at this, please make sure to review the following concepts that we learned before. First thing is how we assign oxidation numbers, and then how can we determine which one undergoes oxidation and reduction, and what oxidation and reduction even means, and also determine the oxidation and oxidizing and reducing agent, or oxidant and reductant, based on the oxidation numbers. Also, how we can write a half reaction for a redox reaction, and how to balance redox reaction in general conditions. So all of these concepts are the ones that we went over before, so make sure to double check those before you continue watching. So in this video, we're going to focus on balancing redox reactions in special state conditions, which is acidic and basic conditions. So these acidic and basic condition balancing redox method is based on how we balance the redox reaction when we are in general condition. So as you can see over here, step 1 through 7 are the ones that we use when we are in general condition. The only thing that is different when we are doing acidic condition is step number 3, where we have to balance it differently according to the protons and the number of oxygens. And again, this is best demonstrated by looking over examples, so please make sure to follow through the examples. And here are 2 examples that we will be looking at together. Hopefully after the first one, you can try the second one yourself and see how it is working for you. Balance the following reaction equation in acidic condition. So looking at this, the first step is to identify the redox couple. To do this, we are going to need to find the oxidation number of all the species on each side. So on the left side, we have manganese, and then we have oxygen, we have chromium. For manganese, we know that the Mn and the 4 oxygens are going to add up to be -1, and each oxygen, according to the oxidation number rule, is going to be -2. Therefore, the manganese will be 7, oxygen will be -2. Chromium, it's a monoatomic, so it's going to be its charge, which is +3. On the right side, we know that the oxidation number of manganese, since it's the monoatomic ion, it's going to be +2. For chromium, since we know that 2 of the chromiums plus 7 oxygens is going to add up to be -2, we can calculate chromium to be 6 and oxygen again to be -2. So by looking at this and cross-comparing, we know that manganese, its oxidation number decreases, meaning that it is gaining electrons, so it is reducing. And for the chromium, since its oxidation number increases, we know that it is losing electron and therefore it's oxidizing. Based on the finding the redox couple, we can write down the 2 half reactions for each of them. The first one is the manganese reducing, so this will be the manganese one. The second one will be chromium oxidizing. So these are the 2 half reactions that we are looking at for each of the redox couple. And for step 3, it says to add and balance the half reaction. There are 3 steps that we need to take. First of all, we are going to balance the redox atoms. And we can see that first of all, on the first one, there's 1 manganese and 2 manganese. So the redox atom, we only mean the one that is undergoing reduction or oxidation. So only manganese and chromium, because those 2 are the one that is undergoing reduction or oxidation. Oxygen does not really undergo oxidation or reduction, so it doesn't really count. So in this case, we are only balancing the manganese. We see that the first one, manganese, is balanced. The second one, we are going to need to add a 2 over here to balance the chromium. For B, it says to balance the oxygens by adding H2O to the opposite side. So we see that over here we have 4 oxygens, so we need to add 4 H2O on the other side. And then on the second one, we see that there is 7 oxygens, so we are adding 7 oxygens, 7 waters to the opposite side. So we are balancing the number of oxygens by adding water to the other side. And the next step, it says that we are going to then balance the hydrogens by adding the protons to the opposite side. So we see that over here we have 8 hydrogens, so we're adding 8 protons to the other side. And in this case, we have 14 hydrogens, so we are adding 14 protons to the other side. And this protons is going to have a aqueous state. So that is atom balancing it. Now we have the same number of O's, H's, Mn, and Crs. Step 4 is asking us to charge balance each half reaction by adding electrons to the reactant or the product side. So in this case, we see that over here we have 8 positive ones, so plus 8, and then 1 minus, so this is going to add up to 7 plus. And on this side we have 2 plus, meaning that we need to add 5 electrons over here to balance it, because with the 5 electrons, that is 5 minus, and the 7 plus, it's going to add up to be 2 plus, which is balancing. So that is the first reaction. The second reaction, we can see that we have 3 plus times 2, 6 plus. There's no charge, so that is just 6 plus on the left side right now. On the right side, we have 2 minus from here, and then 14 plus. That will add up to be 12 plus. That means that on the right side, we need to add 6 plus and 12 plus, so we need to add 6 electrons to the right side, because with the 6 electrons, this will be 6 electrons and 6 minus, so that will be 6 plus. So we are adding 6 electrons to the right side. So one thing to note is that when we are charge balancing, since one is the oxidation reaction, one is the reduction reaction, electrons are always going to be, one of them is on the left side for the half reaction, and for the second half reaction, it has to be on the opposite side. The other thing to note is that since manganese in this case is reducing, that means it's gaining electron. That's why manganese is gaining electrons to reduce. And for chromium, it's oxidizing, so it is losing electrons, and that's why electrons popped out as a product. So things to note about the fourth step. And with that, we can find the common multiplier for the number of electrons. So before we do that, let me first start by copying down the half reactions that we have from the previous slide. So I am, in some cases, I am limiting out the physical state just for clarity. And the second one is 7 water and 2 chromium. And then we got chromium dichromate ion plus 14 protons and then 6 electrons. So in this case, it is asking us to find a common multiple for the electrons, so 5 and 6. The common multiple for 5 and 6 is 30. That means that we're going to multiply the 5 by 6 and multiply the 1 with 6 by 5. And then that is the common multiple. And we will add the two reactions together. So note that when we are multiplying, this 6 is going to go to every single one of the terms. Same idea for the 5. So let me just multiply them in. So I'm multiplying the entire top one by 6. So 5 times 6 will be 30. 8 times 6 will be 48. And then 6 here, and then 24. I'm multiplying the second one by 5. So 5 times 7 will be 35. This will be 10, 5, and then 70. And this is 30. So you see how we have 30 electrons and 30 electrons. The reason why we want to do this is because we want to cancel out the number of electrons when we add them up. So on the 6th step, we're adding them. And we can see that if something is on the product and on the reactant side, we can cancel them out. So you can either do this all together in step 7 or do this right now. I will just do that in step 7 just so that we can be more clear about what we are doing. So we have 30 electrons plus 48 protons plus 6 MnO4 minus. Okay. And definitely, if you are planning on saving some time and ink, you can cross them out as you are writing. I'm just going to do the crossing out later so that way it can be more clear. So I'm doing everything on the left side. So that is everything on the left side. And then going to everyone on the right side. So this is everyone on the right side. So that is 6 manganese, 2 ion, and then 24 water, 5 dichromate ion, and then 70 protons and 30 electrons. Okay. So now I just finished step 6, adding the 2 reactions together. Step 7 is to clean up the reaction, combine the terms, add, and let the reaction coefficient be in the lowest ratio. So let's look at this reaction. We can see that if anything is the same before and after, we can cross it out. So let me just put the box back. Okay. So we have 30 electrons, 30 electrons. We can cross that out. And then 48 protons on the left, 70 protons on the right. So we can combine them to make it 22 protons left on the right side. And then we have the water, which we have 35 waters on the left side and 24 waters on the right side. So this can cancel out to be 9 waters on the left side. With that said, we can now write our final answer because now we are done crossing out the terms. So it's going to be 6 manganate ion plus 9 water. And the 9 water came from 35 minus 24. You can think about 35 as 9 plus 24. The 24 cancel out with the 1 on the product and the 9 is left. And I have the 10 chromium 3 plus. And on the right side, we have 6 manganese 2 ion, 5 dichromate ion, and then 22 protons. Okay, so this will be our final answer after we balance it in an aqueous acidic condition. So in general, the idea is pretty simple as long as you are following the steps. And by the way, this is not a 9, this is an 11. Something happened with my subtraction. Okay, so that is 11. As long as you're able to follow the step and then just make sure that you are not missing any, crossing out thing, keep your work clean. It should be relatively straightforward. Balance the following reaction equation in acidic solution. To do this, first we have to start by identifying the redox couple. So with time proceeding, you might be able to identify the redox couple without needing to do the oxidation numbers. So if you need to do the oxidation numbers, do it. But if you are confident, you can confidently identify them without, then you don't need to really go through the oxidation numbers. So for the oxidation number of chromium, since the 2 chromium plus 7 oxygens is going to add up to -1, chromium is going to be 6, and then the oxidation number of oxygen is -2. For the oxidation number of hydrogen is going to be +1 in this case. Oxidation number of nitrogen, since this is +1, -2, all adds up to be 0. Nitrogen is going to be +3, and oxygen is going to be -2. On the right side, we have the oxidation number of chromium to be +3. Oxidation number of nitrogen, it is going to be 3 times oxygen plus N is -1, so oxidation number of nitrogen is +5. For this part, if you are if you need reminder on how to identify the oxidation numbers and the redox couples, please remember to review to our information on the oxidation number assignment and the balancing redox equations that we were discussing previously. Chromium's oxidation number decreases, so it's undergoing reduction, and then for the nitrogen, oxidation number increases, so it's undergoing oxidation number. For step 2, we are going to start by setting up the half reactions for each couple. So the first couple we know that it is the dichromate ion reducing. And then the second one we have is the oxidation of the nitrogen in the nitrous acid. And we are going to write down the entire substance where the nitrogen is in, instead of just the nitrogen by itself. For 3A, we are balancing the redox atoms. This is only chromium and nitrogen, since they are the only ones that is undergoing the redox reaction, so we don't have to worry about oxygen and hydrogens right now. So for chromium, we have 2 on the left side, 1 on the right side, so we're adding a 2. Nitrogen, we have 1 on each side, so that is already balanced. For 3B, we are balancing the oxygens by adding water on the opposite side. So over here we have 7 oxygens, so we are adding 7 waters because each water has 2 oxygens. And then on this side, we have 2 oxygens and 3 oxygens on the right side. So to balance this, we are adding water on the left side. And lastly, for 3C, we're balancing the protons by adding we are balancing the H's by adding protons. So in this case, we have 7 times 2 protons, so that is 14 protons that we need to add to the left side. And then we have 1, 2, 3, so we need to add 3 protons to the opposite side. So that is everything we have to do for step 3. For step 4, we are charge balancing it, meaning that we're adding electrons. So in this case, we have 14 plus, so 14 times plus 1, 2 minus, so that adds up to be 12 minus on the left side, 12 plus on the left side. 2 times 3 plus is 6 plus. To balance it, we need to add 6 electrons because 6 electrons is 6 minus. So 6 minus and 12 plus adds up to be 6 plus. That is balancing it. And then for the second one, we see that we have 0 and 0. So there's 0 charge on the left side. On the right side, we have -1 and 3 times +1, adding up to be +2. So in order to make them equal, we need to add 2 electrons. Because 2 electrons is 2 negative, so that will make it 0. Remember that when we are adding electrons, electrons are negatively charged. So that is for step 4. Now for step 5, we need to find the common multiplier for the number of electrons. Before we do that, let me quickly write down the equations that we found previously. So we have 14 protons, we have 6 electrons plus 14 protons plus the dichromate ion going to the 2 chromium, 3 ion, and then 7 water. And for the second one, what we have is water plus the nitrous acid. And on the right side, we have the nitrate ion plus the 3 protons and then the 2 electrons. So looking at this, the least common multiple we have to find is between 6 and 2, which is going to be 6. And then we are going to multiply the equation by a number so that it becomes its least common multiplier. So for the first one, it's already 6, so we don't need to do it because our goal is 6. The second one is 2, so we have to multiply the entire thing by 3. So we are going to start doing that. So that means we're multiplying 3 into each of the terms inside the reaction. So that is going to be 3 times 1, 3 times 1, 3 times 1 here, and then 3 times 3 is 9, 3 times 2 is 6. So remember, you have to do it for every single one of the terms. And you can see that now both the sides have 6 electrons. Step 6 is to add the reaction together. So we're going to add the 2 together. And to do this, we are adding everything on the left side and then making it everything on the left side and everything on the right side together. So for everything on the left side, that is these. So when I say left side, it is left side of the reaction arrow. So that is 6 electrons plus 14 protons plus the dichromate ion plus 3 water plus the 3 nitrous acid. And on the right side, I have 2 chromium, 3 ion, 7 water, 3 nitrate ion, 9 protons, and then 6 electrons. So that is step number 6, adding them together. Step number 7 is to clean up the reaction. So if there's anything that is the same before and after, we're crossing them out and we're also cleaning it up. So the 6 electrons, they're expected to cross out because that's how we design it when we are doing the multiplying. And then we have 9 protons on the right side, 14 protons on the left side. So that is going to leave us 5 protons. So you can write 14 protons as 9 protons plus 5 protons. Crossing out the 9 proton, you have 5 protons left. So that is the reasoning behind why we can cross things out that way. And then we have 3 waters on the left side and 7 water on the right side. So that is going to end up with 4 waters. And with that said, now we can clean it up. So I will rewrite it to make it cleaner. And then that is going to be, we have 5 protons left. So 5 protons plus the dichromate ion plus the 3 nitrous acid going to be, okay, I'm definitely running out of space. Okay, plus the 2 chromium 3 ion, 4 water, and then the 3 nitrate ion. Okay, that will be our final answer down here after balancing the reaction in a acidic solution. Next, let's look at how we can balance the redox reaction in basic conditions. So for the basic condition, it is, again, building on top of the acidic condition one. So you can see that from step number 1 to 4, it is similar to that of the acidic condition. And then the main differences between them is actually step number 7, where as we are cleaning up the reaction, we need to make sure to add OH to balance the protons, because we are adding base to balance the protons. And once we add them, we have to make sure that we replace it as H2O. So that way we are evaluating the reaction with our correct chemical knowledge. And this is just one additional thing that we need to do based on the acidic condition one that we learned before. And once again, we are going to demonstrate this by going over the examples. So make sure to follow through the examples to see how it works. And I, again, encourage you to try the first one and then pause the video to try the second one yourself to see how it works. Balance the following reaction equation in basic solution. To do this, the first step, we are again going to start by identifying the redox couple. To do this, we can start by looking at the oxidation numbers. And over here, I am just going to write the oxidation numbers that I determined over here, and you can cross-check it with yours. I will not spend a lot of time going into this just because we have covered it before. So if you need a review, please remember to check back on our previous discussion with the oxidation number determination. Oh, assignment, sorry. So in this case, we can see that in this case, silver is increasing in its oxidation number. That means that it has been oxidized. And then for zinc, it decreases in its oxidation number, so it was reduced. And the redox couple will be the oxidation of zinc. So I have oxidation of silver, which I have silver going to silver oxide. And then the reduction will be zinc ion reduced to be zinc metal. Okay. And for basic solution, to atom balance it, first we need to start by doing the redox atoms as well. So over here we have 2 Ag, 1 Ag, so we're adding a 2, and zinc is already balanced. We are going to again balance the oxygens by adding H2Os. So we have 2 O's, and that means that we're adding an H2O over here to balance the O. And for the 3C, we're balancing the H's by adding the protons. So over here we have 2 H's, we're adding 2 protons on the opposite side. And for step number 4, we are going to charge balance it. So again, on the left side, we have 0 charge. On the right side, we have 2 plus from over here. So to balance it, we're going to add 2 electrons. Because this is 2 minus, adding that would be 0, which is the same as the left side. So that is charge balancing. And then over here, we have 2 plus, and this is 0. So we're going to add 2 electrons on this side to balance it again. With that in mind, we are again going to start by looking for the least common multiple between the two reactions. So the reaction that we have from previously, so remember that we are going to keep all the H2Os, H plus and all that we added to balance the atoms. And from here, we can see that the electrons is 2 electrons, 2 electrons. The least common multiple is 2, and since they're already at 2, we don't need to do any additional multiplication to make them the same because they are already the same. Step 6 is to add them together. So again, everything on the left side stays on the left side when we add them together. So that is going to be H2O, 2 silver metal, 2 electrons, and then zinc 2 ion. On the right side, we have these. was going to be silver oxide, and then I have the protons, the 2 electrons, and then the zinc metal. And for step 7, we are again going to try to clean up. But in this case, when we are cleaning up, we have to note that other than crossing it out, we are going to combine the terms as well. So we can see that the first thing is we are going to add OHs on both sides to balance out the H+. So that means that we see how we have an H+ over here. That means we need to add 2 OHs to balance out the 2H+, and then add 2 OH on the left side too. So that is step 7, adding the 2 OHs. And then with that said, we are then going to combine the H+ and OH- to become water. So the H+ and OH- is going to combine together to become 2H2O. Because remember, H+ and then OH- adding up together is going to become H2O. We have 2 of them. And now we can cross out the H2Os because they have 1 H2O and 2 H2O. So that is what we are going to end up with, and also crossing out the electrons as we used to. So the 2OH is the thing that we're going to do that is different from the acidic condition. And with that said, we are going to then add up what we have left together. So we have the 2OH-, and then we have the 2Ag, the zinc 2 ion, and then on the right side we have silver oxide, and then we have zinc metal, and then we have water as a liquid. And this will be our final answer. Balance the following redox equation in basic solution. Looking at this one, we know that the first thing we're going to do is to identify the redox couple. So in this case, we are again going to find the oxidation number of each atom on both sides. And in this video, I am not going to go into how I found the oxidation numbers. If you need a review on that, please remember to go back and check your notes or our slides that we were previously discussing about assigning oxidation number and also the redox reaction. Okay. And with this, we can tell that the one that is reducing is going to be manganese. Reduced is going to be manganese. And then the one that oxidized is chromium. So chromium and manganese are our redox couple. So we are going to then set up the 2-half reaction for the redox couple. The first one is manganese because it went under reduction. So we have the manganese. And then the second one we have is chromium that undergoes oxidation. Okay. And with this, the first thing we're going to do in step 3, atom balancing it, is to balance the redox atoms. So we can see that manganese, we have 1 on each side. It's already balanced. And then chromium, we have 1 on each side. So that is already balanced as well. So this part is done. And then we're going to balance the oxygens by adding water. So we can see that this side we have 4 oxygens. This side we have 2 oxygens. So we're going to add 2 water to add 2 more oxygens to the right side. And then this side we have 3 oxygens, 4 oxygens. So we're going to add 1 water on the left side to balance out the oxygens. And for 3C, it is asking us to balance the hydrogens by adding protons. So in this case, we have 4 hydrogens from here, so we're going to add 4 protons on the left side. And we have 2 hydrogens, 5 hydrogens, so that is we are adding 5 protons on the right side. And then in step 4, we are going to charge balance them. So we can see that this is 4 plus, this is 1 minus, so adding up that is 3 plus. And then that means that this side we have 0, so we need to add 3 electrons over here because 3 electrons is 3 negative. 3 negative and 3 plus, it's going to add up to 0, which is the same number on the right side. Same idea, down here it's 0, over here we have 2 minus, 5 plus, so that is 3 plus, and we're adding 3 electrons on the right side as a result, because that way we can make both sides charge 0. With all that said, now we are going to look at the number of electrons on each side. So let me start by copying down what we already have. Okay, so these are our reactions, and then the number of electrons is 3 and 3, which makes the least common multiple 3, meaning that we don't need to do any additional multiplications to make the two numbers the same. With that said, we can add these two together, and we know that when we are adding them, everything that was on the left side will stay on the left side. So we're just adding everything on the left side together. And then everything on the right side. So that is MnO2. Okay, so then we have everything on the left side and everything on the right side. Now, to clean up the reaction, we are again going to start by crossing the things that is the same before and after. So we have 4 protons, so we'll cross out 5 to become 1 because there will only be 1 left after we crossed out 4 of the 5. And then from there, we know that we have an H2O, so we'll cross out one of the H2Os. And we are going to add OH minus on both sides to balance the H plus. So on the left side, we don't have any H plus, but this we have an H plus, so we're going to add OH minus to it. So we're going to add an OH minus. And then we are also going to need to add an OH minus on the left side, because if we're going to do it, we are going to do it for both. And then if OH minus and H are both present, then they're going to become a H2O. So these two are going to become H2O. With that said, we can combine the H2O over here and then the H2O over here to make it 2 H2Os total. So with that said, cleaning up the reaction, we are going to get the OH minus, which is something that we added over here, and then the manganate ion. Let's see. The 2 H2Os over here, and then the chromate ion. Okay, and this will be our final answer. So again, the tricky part is this, adding the OH minus and combining them.